According to National Electrical Code Section 310.15b3, the ampacity of 12/2 non-metallic sheath cable in a conduit or wireway is 25 amps. Now, let's address whether the sheath of the non-metallic sheath cable can be removed once it enters the wireway. According to National Electrical Code Section 392.9, the outer sheath of non-metallic sheath cable can be removed after it enters a wireway, but with specific conditions that must be met. Firstly, the wireway must be listed for use with non-metallic sheath cable. Secondly, the conductors in the non-metallic sheath cable must be securely supported within the wireway. Thirdly, the end of the non-metallic sheath cable must be terminated in a listed connector or terminal block. Furthermore, there are some additional considerations to keep in mind. The nipple length connecting the panel and wireway must not exceed 30 inches. The conduit must be securely fastened to both the panel and the wireway to ensure a stable and safe connection. And lastly, the wireway must be accessible for inspection and maintenance, allowing for periodic checks and any necessary repairs. Now let's delve a little deeper into each of these points to ensure a comprehensive understanding. Regarding the ampacity of 12/2 non-metallic sheath cable in conduit or wireway, it is crucial to adhere to the National Electrical Code regulations to prevent overheating and potential fire hazards. The 25 amp limit is in place because the conduit or wireway can restrict heat dissipation from the cable, increasing the risk of thermal overload. As for removing the non-metallic sheath cable sheath within the wireway, this is permitted only under specific circumstances, as outlined in National Electrical Code Section 392.9. Firstly, the wireway's listing for non-metallic sheath cable is a critical safety measure. This listing ensures that the wireway is designed and tested to accommodate non-metallic sheath cable, providing adequate insulation and physical protection. Secondly, the requirement for secure support of the conductors within the wireway is essential to prevent strain on the connections and maintain proper spacing. This support can be achieved through various means, such as cable ties, clamps, or other approved methods. Thirdly, the termination of the non-metallic sheath cable end in a listed connector or terminal block is another important safety measure. This termination ensures a secure and reliable electrical connection, minimizing the risk of loose wires or arcing. Moving on to the additional considerations, the 30-inch nipple length limitation is designed to prevent excessive heat buildup within the conduit. A longer nipple could restrict airflow and lead to elevated temperatures, potentially damaging the cable insulation. Securely fastening the conduit to both the panel and wireway is crucial for mechanical stability and to prevent movement or vibration that could damage the connections. Lastly, the accessibility of the wireway for inspection and maintenance is essential for ongoing safety and reliability. Regular inspections can help identify potential problems such as loose connections, damaged insulation, or signs of overheating, allowing for timely repairs and preventing more serious issues. In summary, when dealing with 12/2 non-metallic sheath cable in conduit and wireway, it is imperative to follow the National Electrical Code guidelines meticulously. Understanding and adhering to the ampacity limitations, sheath removal requirements, and additional considerations will help ensure a safe and compliant electrical installation. Always consult the latest edition of the National Electrical Code and local regulations for specific requirements, and consult with a qualified electrician if you have any questions or concerns. It's also important to note that while this explanation provides a general overview, specific installations may require additional considerations based on factors such as ambient temperature, cable bonding, and other environmental conditions. Always refer to the National Electrical Code tables and calculation methods for accurate ampacity dating and adjustment. Furthermore, when working with electrical systems, safety should always be the top priority. To energize the circuit before making any connections or modifications, and use appropriate personal protective equipment such as gloves and eye protection. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the work. Remember that electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. By following the National Electrical Code guidelines and best practices, you can help ensure a safe and reliable electrical system. The National Electrical Code Section 310.15b3 addresses the ampacity of conductors in raceways or cables exposed to sunlight on rooftops. It specifies that if a raceway or cable is installed on or above a rooftop and exposed to direct sunlight, the ampacity of the conductors must be adjusted according to the temperature correction factors in National Electrical Code Table 310.15b. This is to account for the increased ambient temperature on rooftops, which can reduce the ampacity of conductors. The National Electrical Code Section 392.9 covers the installation of cable trays. It outlines the requirements for cable support, spacing, and securement. Cable trays must be supported at intervals not exceeding the manufacturer's specifications or, in the absence of such specifications, at intervals not exceeding 12 inches for ladder-type cable trays and 6 inches for ventilated trough cable trays. Cables must be securely fastened to the cable tray to prevent movement or displacement. The National Electrical Code Section 312.5c exception deals with the use of conduit nipples for connecting enclosures. It permits the use of conduit nipples not exceeding 24 inches in length to connect enclosures, provided that the nipple is installed in a manner that provides mechanical continuity and a secure electrical connection. The exception allows for flexibility in enclosure placement while maintaining a safe and compliant installation. When dealing with electrical installations involving conduit, wireways, and non-metallic sheath cable, it is essential to consider the proper grounding and bonding requirements. Grounding and bonding help to ensure a safe and effective path for fault current, reducing the risk of electrical shock and fire hazards. The National Electrical Code Article 250 provides detailed requirements for grounding and bonding electrical systems. It specifies the types of grounding electrodes that are permitted, the methods for connecting grounding conductors, and the requirements for bonding metal enclosures and equipment. Proper grounding and bonding are critical for the safety and reliability of electrical installations. In addition to the National Electrical Code requirements, it is also important to consider local codes and regulations which may have additional or more stringent requirements. Local codes and regulations are often based on the National Electrical Code but may be modified to address specific local conditions or concerns. It is essential to consult with local authorities to ensure compliance with all applicable codes and regulations. Furthermore, it is important to use only listed or labeled equipment and materials in electrical installations. Listed or labeled equipment has been tested and certified by a recognized testing laboratory to meet applicable safety standards. Using listed or labeled equipment helps to ensure that the installation is safe and reliable. The listing or labeling mark indicates that the equipment has been evaluated for specific hazards and has been found to comply with the applicable safety standards. When selecting non-metallic sheath cable for an electrical installation, it is important to choose the appropriate cable type and size for the application. Non-metallic sheath cable is available in various types such as non-metallic sheath type, non-metallic sheath type, non-metallic sheath with ground, and non-metallic sheath type, non-metallic sheath underground feeder. Each type is designed for specific applications and has different ampacity ratings and temperature limitations. It is important to select the cable type that is suitable for the environment and the electrical load. Additionally, it is important to select the correct cable size to ensure that the cable can safely carry the intended current. The National Electrical Code tables provide guidance on selecting the appropriate cable size based on the ampacity of the circuit and the conductor's temperature rating. Remember to always consult the latest edition of the National Electrical Code and local regulations for specific requirements and consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others. Ensure all work is done according to code and is inspected by a licensed electrical inspector. Also, never assume a wire is not live. Always check with a meter before touching any wire. If you are not comfortable working with electricity, it is always best to hire a qualified electrician to perform the work. Keep your workspace clean and organized. Remove any clutter or debris that could create a tripping hazard. Use appropriate lighting to ensure that you can see clearly. Wear appropriate personal protective equipment, such as safety glasses and gloves. Use insulated tools when working with electrical circuits. Never work on live electrical circuits unless absolutely necessary and you are properly trained and equipped. If you must work on a live circuit, use extreme caution and follow all safety procedures. Double-check all connections before energizing a circuit. Make sure that all wires are properly connected and that there are no loose connections. Use a multimeter to verify that the voltage and current are within acceptable limits. After completing any electrical work, thoroughly test the circuit to ensure that it is functioning properly. Use a circuit tester to verify that the circuit is properly grounded. If you encounter any problems, immediately de-energize the circuit and investigate the cause of the problem. Never attempt to repair electrical equipment or circuits unless you are properly trained and qualified. If you are not comfortable making repairs, contact a qualified electrician. Always follow the manufacturer's instructions when installing or using electrical equipment. Use the correct type and size of wire for the application. Never overload electrical circuits. Use surge protectors to protect sensitive electronic equipment from voltage spikes. Keep electrical equipment away from water and other liquids. Never run extension cords under carpets or rugs. Inspect electrical cords and plugs regularly for damage. Replace any damaged cords or plugs immediately. Use ground fault circuit interrupters in wet or damp locations. Test ground fault circuit interrupters monthly to ensure that they are functioning properly. Install smoke detectors and carbon monoxide detectors in your home. Test smoke detectors and carbon monoxide detectors monthly to ensure that they are functioning properly. Develop an emergency plan in case of an electrical fire. Know how to shut off the power to your home in case of an emergency. Educate your family about electrical safety. Teach children never to play with electrical outlets or cords. By following these safety tips, you can help to prevent electrical accidents and injuries. Remember, electrical safety is everyone's responsibility. National Electrical Code Section 310.16 provides the allowable ampacities of insulated conductors rated up to and including 2000 volts 60 degrees Celsius through 90 degrees Celsius in raceway or cable or directly buried in earth, based on ambient air temperature of 30 degrees Celsius. National Electrical Code Section 310.15 Current Adjustment Factors addresses the adjustment factors for more than 3 current carrying conductors in a raceway or cable or earth. Ampacity adjustment factors are applied where the number of current carrying conductors exceeds 3 in a raceway or cable. The adjustment factors compensate for the increased heat generated by multiple conductors in close proximity. National Electrical Code Section 314.16 covers the volume allowances in boxes. This section specifies the minimum volume required for outlet, device, and junction boxes based on the number and size of conductors and devices installed in the box. It ensures that there is adequate space for conductors and devices, preventing overcrowding and potential overheating. The values in this section are based on the total volume of the box, not just the usable space. Always refer to the National Electrical Code for the most current information.